Preparing the live stream.
Hello, YouTube. I had to say it.
Okay, I think it looks like we're live on YouTube. Hello, YouTube. All right, welcome everyone to NebraskaJS. This is the first NebraskaJS in over a year, so thank you so much for coming. I wish it were under better circumstances, but we are here. We're almost out of this, it seems, so hang in there. It's going great. Yeah, welcome to NebraskaJS. I'm Nick, and I've been one of the organizers of it for a while now. Not in the last year, obviously, but we're very excited to be back, and we would like to continue doing these more regularly. So if you have a topic that you would like to present at NebraskaJS, we would love to have it. It can be anything from a full-length talk to a smaller lightning talk. We can do shorter lightning talks, or we can pair those together as well. And we really encourage talks of all skill levels. So you don't have to come in being an expert. You can just talk about, how you learned how to use state for 5 minutes. And that would be really cool to hear. So any talk at any skill level is completely welcome here at NebraskaJS, and we would love to have you speak. So if you want to speak, please reach out to myself. You can do that on Twitter. You can post in the chat room here or on Meetup, and be happy to facilitate that. Matt Steele says you can also practice your talk at the Tech Talkers Meetup. Yeah, absolutely. Check that out on Meetup. Oh, that was you. Yeah, so definitely try that. Take a look at that on Meetup. Do you want to post a link to that in the chat? Thank you, Jessica. And okay. The other thing that I wanted to mention before we get started is we do have a code of conduct, and we do enforce that. So please go to nebraskajs.com/COC and read that. If you do have any issues, you can message me privately here in Zoom, reach out to NebraskaJS or myself on Twitter, or reach out through Meetup, and we will address that very promptly. So without further ado, I would like to introduce our speaker for this evening, and that is Jake. Now, Jake, I actually forgot to ask you how you pronounce your last name.
Partusch.
Partusch. Thank you.
Yep.
We have Jake Partusch, and he is talking about full stack serverless with TypeScript. And I'm really excited to hear this talk. We're sneaking in a little Nebraska TS at NebraskaJS tonight, so I'm very excited about that. And yeah, Jake, you should have permission to share your screen if you want to go ahead and take it away.
Awesome. Let me make sure I get the right thing shared. All right. Hopefully this is sharing all right.
I see the slides and not the presenter notes. I think you're good.
Cool.
Yep.
Awesome. So yeah, this is full stack serverless with TypeScript. Yeah, I'm Jake Partusch. I am director of web and mobile at Object Partners. I've been doing development for quite some time now, specializing kind of in front end stuff historically with React and Vue, but more recently, I guess sort of my whole career, I've been doing full stack development for clients. So more recently, I've been working a lot with serverless and TypeScript, and so I kind of wanted to bring everything that I've learned and kind of share it with you all in my free time. I have 2 kiddos. They keep me busy in my free time. I have a golden retriever. We built several snowmen this winter, so I consider myself a mediocre snowman builder. So let's kind of dive right into it. What is full stack? So I would say prior to 2010, there was no, there wasn't a full stack term around. There was just a stack, and there was no front end developers or back end developers or full stack developers. Developers were just developers. The full stack term kind of became more popular around the early 2010s. So I think this kind of came came in with the single page application movement. So AngularJS kind of popularized the single page application. So moving a lot of the logic from to the front end to the client side. And so that allowed people to specialize in front end development. And so if there was a front end and a back end development paradigms, then the full stack was the full stack developer was someone who could work in the front end or the back end and kind of be comfortable. So historically, this has kind of been that front end and back end split, and that makes you a full stack developer if you feel comfortable working with both. But I would say in 2021 is that's kind of changing a little bit and adding in infrastructure as well. So the reason I say this is because in 2021 a lot of our applications that we're building are more cloud native. So we're using services, whether it be AWS, GCP, Azure, and when our applications are written for those services, then we kind of need to know how those applications or those services work to make our applications run well. So I would say in 2021, we kind of not only need to be concerned about the front end and the back end, but also infrastructure. And so some of us might, myself included, might feel a little bit like this. You're a little bit back end heavy, and a little bit lean on the front end, or maybe more commonly here at NebraskaJS, like this, your front end, you're an expert on the front end, but your back end skills aren't quite there. But I guess what I'm trying to, my goal is to kind of give us some skills to hopefully be these majestic horses, and we can be full stack developers through and through, and be productive at the same time. So one of the tools or development paradigms that we can use in doing this is serverless. So why serverless? I'd say from a business cost perspective, one of the most appealing things is that serverless architectures, your costs scale with your scale. So you're paying per request of your application. So in a traditional set or traditional server application, you kind of see this stepstone pattern of scaling. So you have an application with a baseline set of, I need one small server to run my application. And then once you kind of get to peak load, peak scale for that server, you have to upgrade. Either double, you have two small servers running, or you have a medium-sized server running. And then you kind of get that stepstone pattern all the way up to scale with your application as it kind of grows in popularity. But with the serverless architecture, you're kind of from ground zero. It costs nothing, and then when you scale, to a high load, then it costs as much as just as much as you're using and not more. And so where I really think that's important, or where I really think that comes into play, is kind of at the lower end of the scale. That's where a lot of interesting things happen, because you don't necessarily, for test environments and all of that, when you're first starting out, you don't want your application to cost a lot of money. So you can spin up an environment, you can spin down an environment, and you're not going to be spending a lot of money with serverless because you're not using it, or people aren't using it a whole lot. So yeah, during this pandemic times, my wife and I have been watching a lot of television, as most might attest to. So we've been specifically watching a lot of HGTV type shows. And so I kind of wanted to explain the difference between traditional and serverless applications from a cost perspective with a serverless house hunters example. So seemingly when folks are buying a house, at least on TV, they're always like, I need a dining table that can seat 12 people. Even though there were only 2 people that live in this household, we need a dining room table that can seat 12, so that when all the family comes over for Christmas, then we can have everyone sit at the table. And so I'd consider that as peak load purchasing. So they're buying the house or buying the table to fit as many people as will ever be in the house. And so they're kind of over provisioning their house to support that peak load. On the contrary, like a serverless example, as far as house hunting might go, something I learned about recently, I guess I didn't know existed, was that there's people that are Airbnb nomads. And so they don't own a house, they just travel from Airbnb to Airbnb. And I would say that's a good analogy for serverless because, you know, if they have a party coming up, they might rent a bigger Airbnb. If they are just hanging out at home, then, you know, just something small like this. All right. So serverless isn't all just about cost and you know, pay per usage. I'd say it's a lot about productivity as well. So I think when I think of serverless, I think of Lego building blocks. So you have lots of different managed services that you're kind of building together to construct your application logic. So your business logic. Those are the things that kind of make your business different than other businesses, is that core business logic, the application, you know, that user experience piece. So you don't want to spend a lot of time, you know, managing servers or configuring authentication systems. You want to spend all of your time, you know, working on that core business logic. And I think that serverless fits in that paradigm really well. So let's take a look at a common AWS infrastructure using kind of some serverless building blocks. So this is using AWS and some of AWS's managed servers or services. Not all services on AWS are serverless, but I picked some for this example. So this is kind of showing a new user sign-up flow. So we have a user, they come in via their phone and they want to sign up for you know, the service. They want to start using whatever you're building. And so their first interaction with the service is they need to create a new account via Cognito. And then, you know, after they've authenticated with Cognito, they're redirected to CloudFront and can get the website that's hosted in S3 up through and kind of start working with the website. Cognito might tell that user or take that user that was created and pipe it through an API gateway Lambda connection to get stored in DynamoDB. And then that might asynchronously trigger off an email to let the user know, or to give them some sort of welcome email or something like that. So that's just kind of a typical you know, serverless. You take these different serverless building blocks, piece them together to create a new user sign-up flow. So one of the common things I hear about people that are kind of nervous and getting into serverless architecture is, you know, aren't I, you know, really tied to AWS? Is it kind of, am I building my application on AWS and I can't ever move off of it? Well, what I would say about using these serverless pieces as, you know, decoupled building blocks is that you can take the core pieces of your business, and if you need to switch them out with something else, then you can. So in this example, we've taken out our Cognito building block here and replaced it with Auth0, which is a third-party authentication provider. And we've also taken out our SES component and replaced it with SendGrid. So you can kind of pick and choose the different pieces of your application that are important to you. And if a third-party provider does that specific thing really well, then you might choose that thing. We still have our core application logic in AWS, and that's probably okay. AWS does these things really well. Some of those, you know, side services are kind of the pieces that you might want to pick and choose to kind of differentiate yourself or build a better experience with by kind of going custom. You could build a custom building block if it's a really important piece to your business, or you could pick an off-the-shelf third-party piece to kind of put in there. So why TypeScript? There's roughly a million reasons to use TypeScript, and Nick Nisi can name them all, but I'm just going to focus on one for this talk today, and that's because TypeScript is supported, is the only language that I can really think of that is supported on modern front-end frameworks, back-end frameworks, and also infrastructure frameworks. And I'd say that this is infrastructure as code with TypeScript is a relatively new thing. And so that's kind of going to be one of the key pieces that we're going to show here in a minute. So without further ado, let's get on to our demo, but maybe I can just stop right here for a second. And if anyone has any questions, we can talk about them now. Alrighty, we'll keep going, and there'll be a couple more opportunities for questions after the demo and everything. So, so the demo that I built out for this talk is an admin panel for kind of an ordering system. So you can kind of see in this screenshot, we got a couple orders coming in. 1 second, I want to dock this Zoom thing somewhere else. Maybe.
There's no good spot for the Zoom controls anymore. It doesn't matter where you put it, it always covers up the next thing you need.
Yeah, 1 second. How do you actually move it? I've been using Teams for so long that. Is there a way to dock it to the side maybe?
I think you just click and drag it.
Oh, there we go. It's better. Thank you. Okay. All right. So this is our live running demo. And so if I refresh here, you can see it has a little loading spinner, and then it loads our recent activity, our orders for our kind of our order management system. And so this is running in AWS. It's got its own URL and everything. And so what this is a React application with using Snowpack. That's not really super relevant, but it's using GraphQL API running on behind an API gateway on a Lambda, and then pulling those records from DynamoDB. And so we can kind of look at the architecture here. So we have all of those pieces together, and these are kind of our building blocks for our application today. And so what we're going to do here in a minute is kind of go through and make a couple of changes to our demo app, and kind of illustrate how TypeScript and can help us manage our application across the entire stack. And you can just kind of see how those changes flow through. So let's switch over to VS Code. So let's kind of get to the lay of the land here in our VS Code project. So we have at the kind of the base of our project, we have a source folder. So this is our React application. So I'll like create React app. All of these files in here are all TypeScript files, TSX files. So in our components folder, we have the components for our application. So it's kind of your standard top-down application, and then all the components are nested under there. In our functions folder, that's kind of where our API lives. So we have a GraphQL file and a GraphQL.ts file in here. And so this is an Apollo server running in a Lambda, and it's kind of responsible for interacting with Dynamo, pulling those records, and returning the responses. And finally, we have our infrastructure folder. So this is our Cloud Development Kit, our Amazon CDK project. And so the thing that's kind of unique or interesting about CDK is that it's natively written in TypeScript, and it has ports for other languages as well. I picked TypeScript because I like the fact that I can write all my code in my entire project, my front end, my back end, and my infrastructure all in TypeScript. So we can look in here and take a look at our infrastructure stack. And maybe just for a moment, just take a look at how to create a table with the CDK, because this is maybe the most unfamiliar part for many folks, is this infrastructure as code with TypeScript. So we're importing a table construct from the AWS CDK package. So you can kind of see up here, we have the AWS CDK, DynamoDB package, and we're importing table from there. So we're creating a new table, and then we specify some configuration for it. So for DynamoDB tables, partition keys and sort keys are required to create them. So we're defining the name of our partition key and the name of our sort key. I shouldn't say sort key is required. It's not technically required. You can just go with the partition key, but these are some of the configuration properties on a table. Also switching the billing mode to pay per request. So kind of like we want our serverless applications to be, we only want to pay for what we use. By default, the billing mode is provisioned, so you can provision units of DynamoDB, pre-provision that if you'd like. This removal policy isn't really relevant. You probably wouldn't have this set to destroy in production. I'm just doing that for quick prototyping. All right, so we have kind of the lay of the land, understand what's kind of how our project's set up. So the first thing that we're going to do is we're going to make a code change to our project to allow for our, if we go back to our dashboard, maybe it'll make a little bit more sense. Right now, we're only showing pending orders and our orders recent activity page. We're gonna make a change to the project to allow either pending or shipped orders to show up in here. So where we're gonna start is at our GraphQL schema. So this is kind of the contract between our front end and our back end code. And maybe before I get too much further, I wanna note that I'm using another library that's kind of cool in my opinion to integrate our GraphQL schema with our TypeScript types. So that project is called GraphQL CodeGen. And so I have this pulled up. This is their website, GraphQL CodeGen. It's an open source project. And basically what it does is it takes in your GraphQL schema and can spit out TypeScript types. And so we're going to use that pretty extensively here in this example. I should note that in order to do full stack TypeScript, you don't need to use GraphQL, and you don't necessarily need to use GraphQL code generator. I just did this for the example because it's easy to illustrate the benefits of the typing system across your application with these two tools. So the first thing that we're going to do, like I mentioned, is that we're going to switch this query, this find orders query, to take an array of statuses rather than a single status. So we're going to switch this to plural statuses and take an array. So it's requiring that you pass in an array with at least one item. And so that's the only change we need to make to our base schema file. We have a dashboard GraphQL file, and this holds our queries for the dashboard. So we're going to make the same corresponding changes here. And rename these things from status to statuses. Cool. So next thing we're going to do is we're going to run yarn generate. So that's going to kick off our GraphQL code generator. So it's going to slurp up these GraphQL files and spit out TypeScript definitions that kind of correspond to our GraphQL schema. And so we see that this ran pretty quickly and it spit out those TypeScript files. So the next thing we're going to do is run yarn build on our project to make sure to see, we change some stuff in our GraphQL schema, we would expect some things to break. And we do. So the first thing that we see is our resolver, our Lambda function has a type error now. So we have our status, we rename that to statuses. So our types that were generated for our GraphQL function are no longer matching what we had coded. So we're going to change that from status to statuses and change this from status to statuses as well. Now our function was expecting a single status, but we needed an array of statuses now. So luckily I wrote something ahead of time and we can just fetch orders by status codes instead of statuses. So this is kind of cool. GraphQL code gen took our schema and generated the resolvers, fully typed resolvers for our schema. And so we got type safety for our GraphQL function in here. And so that's pretty neat. So let's head back to here and see, okay, we have another error in our dashboard.tsx file. So our dashboard TSX file is kind of the main root entry level for our dashboard. If we remember, our dashboard is our application running here. So it's got, you know, this recent activity stuff in here. So we have a TypeScript error and it's saying, you know, we're passing in a variable called status with status pending. If we remember the thing that we're trying to fix, or the business requirement we're trying to solve, is to pass in both status and shipped statuses to our dashboard. So let's go ahead and change this to an array. You see we've got some autocomplete in here too. So now we can pass in our array of statuses, both pending and shipped. One thing that I should note is it's using our GraphQL code generator also can generate, you can define plugins for, let's go and look at that real quick. Can define plugins, and one of them is React Apollo. So the React Apollo plugin will generate these hooks for you. So we have a hook that's called use find orders query. So it generates that hook and fully types all of the variables that you pass into it. So that's really cool. We can have fully typed integration on our front end to make sure that we're interacting with our GraphQL schema like we had planned. So let's run yarn build one more time. The front end completed and the infrastructure, his code is done. Awesome. So for our first example, we kind of recap what we did here. We changed status to statuses. We passed in an array of statuses into our query. We ran the code generator. It updated all of the types for our application. For our GraphQL resolvers, we caught an error where we were referencing status instead of statuses, and we needed to fetch orders by status codes instead of a singular status code. Also, in our dashboard, we were passing a status variable instead of statuses and not an array. And so we kind of caught errors on both the front end side of our code and the back end side. So we had that fully typed for both things, and that's pretty neat. All right, so for our next example, this is more of a, not necessarily a business requirement, but kind of a code cleanup thing. So for our order object, we specified an attribute called customer full name. And so we decided as a development team, we wanted to switch this to be its own type. And so we're going to make a new type called customer. And so this customer has an ID, first name, last name, and full name. Cool. So we have a new type called customer. It has these couple of new attributes and then also has the full name again. So we're going to switch our order to use a customer instead of the customer type, instead of having customer full name kind of in our order at the root level. So we made our change to our base schema. Again, we'll have to open up that dashboard GraphQL file, and we're going to have to change this fragment where it was pulling the customer full name to grab our complex, attribute customer, and then we don't need the first name, we don't need the last name or the ID, we just need the full name from here. So those are the two changes we're going to make to our GraphQL schema. So if we run yarn generate again, it should spit out some new types for us. And while we're in here, we can run yarn build to see where our new type errors are. Cool, so we have one here, a new file we haven't looked at yet. It's called orderRow.tsx. So if we go back to our application, our order row component is this row. It has an order item in it. It says order from Molly Sanders. So right now, we see there's an error, order from, and then it's referencing customer full name in here, and we want it to reference our new path, which is customer.fullname. So I think that one is very special because if this were written in JavaScript, I almost certainly would have forgotten to change this way deep down here in our component tree, and I would have found that bug at runtime, and hopefully not in production, but maybe in production as well. So I'm a fan of that. All right, so let's run yarn build again, see if we have any more errors. Okay, so it looks like we have an error in our infrastructure project, which we haven't had yet. So it looks like our front end and back end built fine, but then when it tried to build the infrastructure project, we got an error here in our infrastructure stack. So let's go take a look. Sometimes it takes VS Code a minute to catch up. There we go. So to kind of give a little bit of background on why this error is happening, we have to understand a little bit about DynamoDB. So for DynamoDB, you can by default query on the partition key and sort key in combination. But if you want to do more complex type queries, you have to create secondary indexes. And so that's what I had done already, is created a secondary index to query on for some of the more complex queries for this application. And so we see we're defining our global secondary index here. It's got a name. It's really very similar to the way you define a table. You define the partition key and the sort key. The thing that's kind of unique about this one is we didn't want to copy over all of the attributes from the table. We only wanted to copy over the attributes that we specified in here. So copying over all of the attributes in an index can be, you know, kind of over provisioning or more expensive than we need it to be. So we're only copying over the ones that we need. So we kind of specified those in a list here. And this type, if we kind of dig into why this error is showing up a little bit more, it's defined up at the top. And it's saying that we want the available attributes to be our keys on our order object. And so that order object, that order type is defined, generated based off of our GraphQL schema. And so we can only specify the keys if they exist on our order type. And right now, since we changed what our order looks like, customer full name is no longer there. So to fix that, we can look at the different attributes we have on order, and we see that we have customer now and not customer full name. So that fixes our attributes that we're copying over to our secondary index. And I guess I just want to reiterate that this is kind of a cool bug or a type check that we found here. Basically, by changing our GraphQL schema and regenerating some types, we were able to find a potential bug way down here in our front-end code. And then we were also able to make sure that we had taken into account that this secondary index is changing in our DynamoDB table or needs to change. Likely this might have been forgotten if it was in a YAML file or some JSON config. We don't type check those, and so we might not have found that. And the next time we queried on this index, that the attribute that we're expecting to be there may not have been there. So I think that's really cool and kind of shows the power of using TypeScript across the entire application, both the front end and the back end, and the infrastructure, is that we can kind of define those. You can have that type safety across the entire stack. That helps you basically find all of the bugs in your IDE before you even build and push to production. So to kind of bring it full circle, like a good celebrity chef, I already have baked this application, and we're going to take it out of the oven now. So you see we have this preview URL that I generated for this application, and you see we have our orders, both pending and shipped orders are in here. So yay. Awesome. So back to here. This time, I'm going to stop for a few seconds. I do have a little bit more, but it's kind of extra content. So if we have any questions about what we've talked about so far, now would be a great time. I was told that on video calls, you're supposed to count to 12.
There is a question in the chat.
Awesome.
From Wayne. I'll read it. Can you walk through the yarn build to show how they are connected?
Yeah, I can. So the build. So the two things it does is it does a Snowpack build. So we're using Snowpack under the hood for the front end code. And the reason it finds also those, we're not using, I should switch this to use Yarn workspaces or Lerna. And so we could kind of run these all in one command. But basically, since it thinks that this functions folder is part of the React project, so it goes ahead and does the type checking for that as well in the Snowpack build command. And so that build command will, after it runs the type checking and everything, it'll spit out all of the JavaScript and HTML files that are required to deploy your React application. And then after that, it goes into our infrastructure folders and runs a synth. And so that's a special CDK command that basically generates the CloudFormation templates from your TypeScript code. So it executes all of your TypeScript code in your stack and generates CloudFormation templates off of that. So we want to take a look at that real quick. Generates a huge JSON file that you don't have to write by hand anymore. You can just write TypeScript and it'll generate the JSON for you. And that's what ends up getting deployed to AWS.
I have a question kind of about the functions themselves. Like when you're developing those, maybe I missed it, but how do you work on those locally, or do you have to like deploy each time to test those?
Yeah, there's a couple of different ways. So so for this example specifically, I could run this locally because it's just basically Apollo server. So I could run this function locally. A lot of times though with serverless architectures, since the deploys in the cloud environment are happening faster and faster every day, a lot of times I'll just push up a deploy preview, kind of like I had here. And so you know that you're running on all the infrastructure that, a real DynamoDB table, real Lambdas, and you have a unique URL that you can use to test your application. So a lot of times I will just deploy it, and that may take a little bit longer than developing locally. If I'm feeling like I'm not very confident in my code, then I'll write some jest tests around the functions and see, just to kind of get that initial, like, I have accounted for all the things I think I should account for. And then after those jest tests pass, then I might just push it up as a deploy preview. So I'll kind of talk in a second. If we don't have any other questions, I can talk how this function itself gets deployed, because TypeScript isn't natively supported by AWS and Lambda functions. So we can kind of talk about how that all works if we don't have any other questions. If you do have questions,
I would like to hear
go ahead.
that, but I would just throw out there that AWS Lambda fairly recently, like in the last few months, now has like first-party support for containers. So there are Docker base images that can run a Lambda function locally. It's really slick if you haven't tried it.
Oh, cool.
Awesome. Yeah, I have not tried that. And I think that the running locally stuff. So I've used local stack to kind of run Docker containers locally for developing Lambdas and DynamoDB. I think it gets you most of the way there. And if you really want to run locally, then those are good options. The things that I've run into is just the discrepancies because you're trying to basically recreate AWS on your local machine. And so you just kind of have discrepancies that you might spend a lot of time debugging the way this queue is working on your local machine, but in reality on AWS it's working just fine. So just kind of those things. And yeah, I think that the Docker support on Lambda is kind of a cool thing. I haven't used it yet myself. Yeah.
I totally agree. I shy away pretty strongly from trying to like end-to-end test the whole complicated stack locally. But if you just need to invoke a function with the first-party container support now, it's really, really easy.
Yeah, definitely. Awesome.
Yeah, sorry to butt in. If you're curious, there is a new project I found that lets you build CDK, and it'll actually be able to set up a proxy. It'll proxy request from AWS into a local Lambda. So kind of takes care of that for you. It's called Serverless Stack. Posted in the chat.
Awesome. I have heard of Serverless Stack, and it sounded like David. How's it going?
Hey, good to see you.
Yeah, that sounds like a really interesting project. They've been doing a lot of cool stuff. So I haven't used it yet, but it sounds really cool. Awesome. So yeah, I'll just talk for just 2 minutes about something I've been working on recently, and then we can kind of talk about everything, keep talking. So yeah, I like all of the questions. So something I've been working on and released about a month ago is called Serverless UI. So I took what I've learned around building websites, kind of driven from the website side of things, and built this command line utility / AWS CDK construct around that common AWS infrastructure. So this works on AWS specifically, but kind of how it works is under the hood, it's using the CDK constructs and kind of scaffolding out like a project, kind of like our infrastructure project here. And it has some custom CDK constructs to do the those more common things like we were talking about earlier, the CloudFront S3 Lambda API gateway stuff. It does all that for you. And so if you're kind of out of the box using your serverless application, you have your functions in a functions folder, and you just want to use the CLI, then it'll deploy all that for you. All you have to do is really configure your AWS credentials locally, and then you can install the CLI and deploy, point it to that directory. So the way that this application that I kind of went through in the demo today is working is kind of a little bit more advanced version of the same thing. And so we do have a CDK project stood up here, but it's using that custom construct. And so you see we have a serverless UI construct that we're importing from the package. And we kind of define these properties. So we define where our UI sources folder is. And so that's that build directory that Snowpack creates. And then also where our API files are, and that's that GraphQL.ts file, which is in our functions folder. And so this is still, relatively in its infancy, this project, but I've been using it all my side projects recently. It's been working out really well. And so it also has the ability to configure custom domains and SSL certs. And so it's been working good for what I've been doing so far. And so yeah, enough of shameless plugging. And I kind of want to wrap it up and say, I think that we may be coming to a point where, the generalists are needed to kind of wire together all of these different services, all these third-party services, all these AWS services, kind of wire them together, be those Lego builders. And I think that we may be coming to a point where we just become developers again, and not full stack developers, front-end developers, back-end developers. We're just developers using all of the tools that are at hand to build awesome applications. So I'm not sure if that's where the future's headed, but it kind of feels that way sometimes. So just wanted to put that out there. But otherwise, I don't have anything else. It's been great speaking with everyone, and I'm here to stick around for a while if we want to chat about whatever. Thank you.
Thanks, Jake. Are there any questions? Feel free to unmute and ask them.
Kind of want to get in the weeds a little bit with GraphQL resolver patterns, but I can save that for maybe after the official presentation because it's not exactly on topic for this.
Cool. So I do have a question. Jake, I always kind of wonder about the where you would draw limits or boundaries. When you think of a type of application that kind of a serverless architecture like this wouldn't work, and in that case, what would your kind of backup be that would get some of these same sort of full stack benefits?
Yeah, so the use cases, I guess, for not being serverless, at least, so I'm pretty all in on the serverless game. So I'm definitely biased, but I feel like the use cases are getting fewer and fewer. Some of those might be if you have like something that's highly state driven, or highly CPU or GPU intensive. So like machine learning is kind of historically one of those things that doesn't really suit serverless very well, but I feel like that's also been changing. There's been a lot of people experimenting with running, their machine learning models kind of distributed with Lambdas, and that sounds really cool to me. As far as like, if you have a traditional server architecture, you can still kind of get some of these benefits of an application. You may just be, front end and back end, but if you have and the ability to write, to generate the code that kind of is derived from a schema. So you may start from a GraphQL schema or an OpenAPI Swagger spec. And even if your application is written in two different languages, you can kind of get that same sort of feel if you are able to maybe generate your Java types from your OpenAPI spec, and then your TypeScript types for your front end from that same specification. You can kind of get some of that. You don't obviously get the infrastructure and you're not writing the entire application in the same language, but you can kind of get some of those same types of benefits.
We have another question in the chat from Wayne. It says, are you using AWS AppSync? If not, what led you away from it?
I have used AppSync. It's been a bit. I think the thing that led me away from AppSync, at least when I did try it, was I kind of needed more control. It does a lot for you, and maybe, I don't know, maybe I need to revisit AppSync again. I know it's grown a lot, and the Amplify ecosystem has grown alongside it. I do think AppSync is a good way to get started with, if you have a schema and you just want to try something out really quickly. I've kind of just always liked to have that control in my Lambda functions. And I know that they've released lots of features recently, so maybe I need to take another look. But
Schema federation is a good reason to not use AppSync right now, but I think that's going to change pretty quickly.
yeah, that's a good point.
Any other questions? All right. Well, thank you so much, Jake. That was a great presentation. I really enjoyed it, and I learned a lot. I need to go dig more into serverless for sure. That's something that hasn't been fully on my radar. And I this helped a lot to as something that I could see myself digging into and at least playing around with it and seeing what the benefits are.
Yeah,
So
for sure. I just want to note that like getting started with serverless applications is awesome, and you can build as many little things as you want to, and you don't pay for them, and that's kind of ideal
Yeah.
for side projects. Is I have probably 50 different versions of this example project deployed in AWS, and it's costing me pretty much nothing. So that's always good. You don't have to spin up databases and servers and worry about, oh, did I turn that thing off? That's awesome. So
yeah.
I did check the YouTube stream. Somebody actually popped in and asked a question in the chat there. They want to know what you're using to connect to the database. Is there an ORM?
I'm not using an ORM, and this is kind of so I'm kind of relying on TypeScript a little bit to define my DynamoDB items that are in there. So DynamoDB doesn't have, there's no schema associated with it. It's just those keys are required. So it is important to have type safety around those items that you're putting into the database and also getting out of the database. But yeah, just kind of utilizing TypeScript to make sure that those things are in good order before putting them in, but no ORM.
I need to have my Careless Whisper track queued, but I don't. All right. Well, thank you. I think I will end the presentation here in terms of the streaming, but feel free to stay on and chat some more. We'll just turn off YouTube and stop the recording. But thank you so much for joining us. And again, please reach out if you would like to speak at NebraskaJS. We would love to have talks of all skill levels and of all lengths. If you want to do a lightning talk, we'd love to have you do that. So thank you so much for coming out today, and we'll see you next time. But again, feel free to stick around.